Hello everyone, this is Mohua Nandipal, Assistant Professor, CSE, MCKV Institute of Engineering, Howrah, India. In this video, I am going to discuss regarding the introduction of operating system. An operating system is an important part of every computer system. Before discussing about the operating system, I would like to discuss about different components of a computer system. A computer system can be divided roughly into four components: the hardware, the operating system, the application programs, and the users. This is the abstract view of the components of a computer system. The hardware, the central processing unit, that is CPU, the memory, and the input-output devices provides the basic computing resources. The application programs such as word processors, spreadsheets, compilers, web browsers, etc. define the ways in which these resources are used to solve different computing problems. The operating system controls and coordinates the use of the hardware among the various application programs for the various users. Now, I would like to discuss regarding different variations of operating system. These are mainframe system, desktop system, multiprocessor system, distributed system, clustered system, time sharing system, real-time system, and embedded system. Now, we trace the development of operating system starting from mainframe operating system. Mainframe computer systems were the first computers used to tackle many commercial and scientific applications. We trace the growth of mainframe systems from simple batch systems where the computer runs only one application at a time up to the time-shared systems which allow user interaction with the computer system. In case of batch systems, to speed up the processing, operators batch together jobs with similar needs and ran them through the computer as a group. Thus, the programmers would leave the programs with the operator. The operator would sort programs into batches with similar requirements, and as the computer became available, all the programs are run in a batch. The output from each job is sent back to the appropriate programmer. In this execution environment, the CPU is often idle because the speed of the mechanical I/O devices are slower than the speed of the electronic devices. Now, regarding the multi-programmed systems, the idea is like this. The operating system keeps several jobs in memory simultaneously. This set of jobs is a subset of the jobs kept in the job pool. The operating system picks and begins to execute one of the jobs in the memory. Eventually, the job may have to wait for some task, such as an I/O operation, to complete. In a non-multi-programmed system, the CPU would sit idle during this time. In a multi-programmed system, the operating system simply switches to and executes another job. When that job needs to wait, the CPU is switched to another job, and so on. Eventually, the first job finishes waiting and gets the CPU back. As long as at least one job needs to execute, the CPU is never idle. Now, regarding the time sharing system. Time sharing systems are also called multitasking system. A time-shared operating system allows many users to share the computer simultaneously. Since each action or command in a time-shared system tends to be of short duration, only a little CPU time is needed for each user. And as the system switches rapidly from one user to the next user, each user is given the impression that the entire computer system is dedicated to her use, though it is shared among many users. Next is regarding desktop systems. Personal computers, that is PCs, appeared in 1970s. The MS-DOS operating system from Microsoft has been covered up by multiple versions of Microsoft Windows. The Apple Mac operating system has been ported to some advanced hardware, some advanced features, etc. Linux is a Unix-like operating system which is available for PCs, and it has also become quite popular among users. Now regarding multiprocessor systems. Most systems to date are single processor systems, that is, they have only one main CPU. However, multiprocessor systems, they are also known as parallel system or tightly coupled system. They have actually more than one processor in close communication, sharing the computer bus, the clock, and sometimes the memory and the peripheral devices as well. Multiprocessor systems have three main advantages. Increased throughput of multiprocessor system can be explained in this way that by increasing the number of processors, we hope to get more work to be done in a less time. To speed up ratio with n processors is not n. Rather, it is less than n. When multiple processors cooperate on a task, a certain amount of overhead is incurred to keep all the parts working correctly. This overhead lowers the expected gain from additional processors. Another advantage that we can gain out of multiprocessor system implementation, that is economy of scale. Multiprocessor systems can save more money than multiple single processor systems because they can share peripherals, mass storage, and power supplies. If several programs operate on the same set of data, it is cheaper to store those data on one disk and to have all processors share them than to have many computers with local disk and many copies of the data. The next advantage that we can get out of this is increased reliability. If functions can be distributed properly among several processors, then the failure of one processor will not halt the system, only slows it down. If we have 10 processors and one fails, then each of the remaining 9 processors must pick up a share of the work of the failed processor. Thus, the entire system runs only 10% slower rather than failing altogether. Multiprocessing system has two different variations. Symmetric multiprocessing, that is SMP, and asymmetric multiprocessing, that is AMP. The most common multiple processor systems now we use is symmetric multiprocessor system, in which Each processor runs an identical copy of the operating system, and these copies communicate with one another as needed. This is the diagram for symmetric multiprocessing architecture. Some systems use asymmetric multiprocessing as well, with one another as required. In asymmetric multiprocessing system, each processor is assigned a specific task. A master processor controls the system. This is the very important point. In asymmetric multiprocessing, a master processor controls the system. The other processors either look to the master processor for instruction or have predefined tasks. This scheme defines a master-slave relationship. The master processor schedules and allocates work to the slave processors. Now, we are discussing about distributed operating system. The most important point regarding distributed operating system is that in distributed operating system environment, multiple computers communicate through network. A network is a communication path between two or more systems. Distributed systems depend on networking for their functionality. They are able to communicate with each other through network. Distributed systems are thus able to share computational tasks and provide different features to the users. TCP/IP is the most commonly used network protocol. Most operating systems support TCP/IP, including the Windows and Unix operating system. Networks are typecast based on the distances between their nodes. A local area network LAN exists within a room, a floor, or a building. A metropolitan area network can link buildings within a city. Similarly, a wide area network WAN usually exists between cities or countries. In contrast to tightly coupled system, that is multiprocessor system, the computer networks used in these applications consist of a collection of processors that do not share memory or a clock. Instead, each processor has its own local memory. The processors communicate with one another through various communication lines. These systems are usually referred to as loosely coupled systems. There are two types of distributed operating system. Those are client-server operating system and peer-to-peer operating system. Another variation of operating system is network operating system. A network operating system is an operating system that provides features such as file sharing across the network, and that includes a communication scheme that allows different processes on different computers to exchange messages. A computer running a network follows the network operating system, which acts autonomously from all other computers on the network, although it is aware of the network and is able to communicate with other networked computers. Now we are comparing distributed operating system and network operating system. In distributed operating system, users are unaware of multiplicity of machines in network. In network operating system, users are aware of multiplicity of machines in network. Distributed operating system can access remote resources as they access local resources. Network operating system can access remote resources by remote login or by remote file transfer. Distributed operating system is difficult to implement, whereas network operating system is simpler to implement. Distributed operating system is simpler for users to access and utilize, but network operating system is difficult for users to access and utilize. Next variation is clustered system. Clustered systems share storage and are closely linked via LAN. Two or more individual computer systems are coupled together and linked through local area network. Next variation is real-time operating system. A real-time system has well-defined and fixed time constraints. Processing must be done within the defined constraints or the system will fail. Real-time systems come into two different variations: hard real-time operating system and soft real-time operating system. A hard real-time system guarantees that critical tasks must be completed on time, and a less restrictive type of real-time system is a soft real-time system. Given their lack of deadline support, soft real-time operating systems are risky to use for industrial controls and robotics. They are useful, however, in several areas like multimedia, virtual reality, advanced scientific projects, etc. These are some of the examples of soft and hard real-time operating systems. Next variation is embedded system. Embedded computers are the computers which run embedded real-time real-time operating systems. Means the computer with embedded real-time operating systems. These devices are found everywhere, from car engines and manufacturing robots, even in microwave ovens, etc. These operating systems are usually primitive and they provide only limited features. The use of embedded systems are expanding continuously. For example, entire houses can be computerized so that the central computer, either a general purpose computer or an embedded system, can control heating or cooling system, the lighting and alarm system, and even the coffee maker system of the house also. These are some of the examples of embedded systems. Now I would like to discuss the same logical extension of time-sharing system and multitasking system. Time-shared system allows many users to share the execution time. The system switches rapidly from one user to other. Each user is given the impression that the entire system is dedicated to her. Multitasking CPU executes multiple tasks by switching among them, but switches occur so frequently that users can't perceive it. So, time-sharing system and multitasking operating system both are having the same logical extension. Now, I would like to give stress upon multiprogramming operating system. I am discussing the features of multiprogramming operating system once again. Multiprogramming operating system is a fairly sophisticated operating system. A process is executed until it must wait typically for the completion of some I/O request. The CPU would then sit idle. All this waiting time is wasted. To use these times productively, several processes are kept in memory at a time. When one process has to wait, the operating system takes the CPU away from that process and gives the CPU to another process. This pattern continues. The objective of multiprogramming system is to maximize CPU utilization. The reference book that I have used for my lecture is Operating System Concepts by Silversage, Galvin and Gagne from Wiley Publication. With this, I am concluding the session of the discussion regarding introduction of operating system and different variations of operating system. Thank you.